What's up, guys? Welcome to JS Racing. Now, a couple of months back, I made a post on my Instagram account. I do have an Instagram account. I posted that I was learning how to use Solidworks. Solidworks is actually a very complex modeling software for, mechanical parts and all that stuff, and I think mechanical machines as well. But yeah, it's a crazy software. I was trying to learn it, but until today, I still can't model anything from scratch. I still haven't learned that. I mainly use it to convert models that I've built on SketchUp and convert it into, I think they call it features. At least it's a solid model so that, it can be used by CNC machines to create their G-code. CNC machines cannot use models from SketchUp to create the G-code. So there are two things that I actually created successfully from SolidWorks. Well, not create, but like converted. And the first one is an engine mount. So let me just show you something real quick. This is a commercially available engine mount locally, and you would find these basically under every four-stroke engine that you'd see locally. These are very heavy, very big, and they use very crappy aluminium to create these. I mean, it's probably just melted from like soda cans, and it's really poor quality. So that's why they have to use it, make it so thick, so fat. So these are very heavy, so let's weigh them. Just so happen to have a digital scale, so I'll just weigh them, and I'll add the two bolts to the weight, and I'll show you the weight real quick. So one set, including the bolts, everything, not including the nut to lock it in place. I mean, it's quite significant, but just it is about 1,880.7 grams. That's very heavy, close to 2 kilograms. Well, close to 4 pounds. So after having created my own engine mount, I'll show you what it looks like. It's a lot smaller. So just one side of the engine mount, you can see there's a significant difference in size. Now, my engine mount is created from 6061 aluminium, so it's very strong. Also, I've made it a lot higher so that it will prop up the engine slightly higher than normal. This is the back, and this is the front. This little opening is really for, like, my original intention was for more air to travel underneath the engine so that it can provide a bit more cooling. As to how much cooling it does provide, I don't know. It could be negligible, but at least it's something. But the other benefit for this ramp that I found out was that as you're actually letting out the engine oil from the opening at the bottom of the engine, it'll actually channel all the oil within this ramp, and it won't go anywhere. It's very clean the way it does it. Whereas for the original engine mount, the oil, as you let it out, it'll travel along the edges and it'll just go all over the place. So this is actually quite a good feature, honestly. But anyway, so another feature that I've put into this engine mount is that I have 3 positions for all of the, the bolts. So if you need to shift the engine laterally, you can do so. Okay, all this is measured precisely. And this side actually is a lot longer than the typical one, so that it has more surface area here to grab onto the chassis. So this engine mount is actually very tight once you have it installed. So yeah, I've put in a lot of my own ideas into this mount, and yeah, I've been using this for my dyno because the previous mounts, because of the vibration in the dyno, it would always shift, but with this particular mount, it won't shift at all. It's very strong. It'll just grip in place and it won't shift at all. So I like this mount very much, and I actually made 3 sets. This is my 3rd set. Anyway, I'll just show you how little it weighs. So let me just grab all the bolts first. I'll show you how little it is. So these are the 2 bolts on the top. I ran out of the short bolts, which are supposed to be for engine mount, so I got the long ones. So it doesn't matter. It's a handicap I get for this particular mount. So let me weigh it, zero it. It's 1,064.5 grams. So it's over 800 grams lighter. That's quite significant because if you pair it up with the carburetor manifold that we designed, you're going to be able to save up to close to 1 kilogram of weight from your engine. And in motorsport, weight affects a lot of things, and you want to be as light as possible. So shaving off 1 kilogram is quite significant. So this is a very lightweight, very strong engine mount that I've managed to learn how to create from in the way Solidworks. But anyway, so that's the first thing. The second thing that I converted from SketchUp to Solidworks, and then subsequently the STP file format, is a very simple tool, a crankshaft lock. So as the name suggests, it's just a lock where you put onto the crankshaft, you lock it in place. So you do this, just go to the position you want, and you lock it in with bolts. So yeah, that's basically what it does. But it does help a lot when you want to torque down the flywheel, because it will hold the crankshaft in place very, very sturdily. So yeah, it's not going anywhere. So if you need to change the timing of your flywheel, all that stuff, this is a very good tool to have. I mean, a lot of people have their own solution with like an old clutch or some other, waste metal. But yeah, I mean, this is a very nice design that I, wanted to try. So yeah, it turned out really nicely. So yeah, I really like this design. So anyway, this is just a really short video just to show the results of learning how to use SolidWorks. It does help expand the ways where I can actually put my ideas into action, because with SketchUp itself, the furthest you can go is really just 3D printing. But when you pair it up with other softwares, you're able to create a lot more. I mean, this is probably common knowledge for a lot of people, but this is a first for me. So I'm pretty happy with the results. But anyway, yeah, this is a short video, just a very short update. And I'll see you guys in the next one. Peace.